Is it evidence of early philosophers that the world isn't round? Or is it a mirage?
If you follow this right here, it's really easy, right through here.
We climb the dunes to find out.
A mirage is a case of atmospheric refraction, and it's caused by the fact that you have temperature variations in the atmosphere, and these cause density variations.
Dr. Mark Rennie is an associate professor of aerooptics at the University of Notre Dame.
So literally the speed of light varies within the air, and this variation of the speed of light has the effect of bending light rays.
Sometimes the Lake Michigan waters makes us see things. Here we are at the top of Warren Dunes. Pretty exciting as the inversion is setting up as we speak. A spring night, the lake waters are still very cold, but we can see out on the horizon and above it a dark line that's starting to show up just above. That's the inversion. That's where temperatures are different below than they are above and creating that cap. And we're beginning to see that atmospheric lensing, where in spots along the horizon we're seeing either breaks in the buildings or where the buildings may be flipped or distortion caused by the mirage or atmospheric conditions that are changing as we speak.
What's happening is the light from Chicago is being bent by the cold air above Lake Michigan slightly downwards towards the observer here in Michigan, and that's helping the light rays get around the curvature of the Earth, so to speak, so that Chicago can be seen almost all the way down to ground level.
Let's hear that again.
What's happening is the light from Chicago get around the curvature of the Earth, so to speak, so that Chicago can be seen almost all the way down to ground level.
See, now there's buildings shown up straight ahead of us. But if it is a mirage, argues many of the biggest critics who've emailed me, the image should be upside down.
The word mirage originates from the same root word as the word mirror. So technically, I think if you're going to be a stickler about it, you would say a mirage has to have an inverted image. But again, the physics is all the same.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes. So this is, if anything, this is definitely a demonstration that.
I went on Amazon and I got these plastic magnifying sheets and came up with another way of doing the same thing. Using the sheet right here. Set the city up, a little cutout of the city, and now I've got the big magnifying glass sheet. Bring the camera right up to the lens. See, that's the normal view of the city. Now let's back up again.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here,
the atmosphere really is acting like a lens.
Yes.
Atmosphere really is acting like a lens, and this is how much of the city is missing due to the lensing effect, the magnification of stand to paste the sun on it and keep it the same height over the flat surface of a table. So the sun is always going to be parallel with the surface. And check this out. All right, here's the first test of a sun moving over a flat surface. And with no atmospheric magnification, it does what we might expect it would. It gets smaller as it goes away from us. All right, now let's see what happens when we add in our atmospheric magnification. Again, water and refraction. Water causes magnification and refraction, right? So let's bring the sun back. Oh, check this out. Refraction bends the light downward. It made the sun set on a parallel surface as it was moving parallel, the same height, the whole way over a flat surface. The refraction caused the sun to set. Not only that, well, let's bring in the beginning of that little test, and we see that it maintained pretty much the same size, too. A table with my trusty plastic lens set up here. And I took my stand that I was using for the sun and moon and just set it up right here on top of these little Tupperware things. And I was thinking, okay, so let's just say the bottom of this little stand here represents the bottom of the clouds. And so as you can see here, the light is way above, it's well above what would be the bottom of the clouds in this example. So let's see what happens. I turned off the lights and set my iPhone to record, and I'm showing myself here recording all of this with another camera, and I pulled the light back on the table, and watch what happens here. Ooh, check it out. There's that refraction taking place again. It's got the light. It made the sun set, first of all, below the horizon in this case. And let's just show, this is just the iPhone view. I'm going to bring the cloud in here, and the platform represents the bottom of the clouds. So the sun's going down, and whoop, there it is. The bottom of the clouds illuminated by a light source that's well above the clouds, moving parallel over a flat surface.